Good day. In this video, I want to show how to express such a fraction in its partial fractions. By the way, the advantage of being able to express a composite function into partial fractions is so that we can perform integration very well. Under calculus, we do integration. So it's difficult to integrate such an expression, but if we break it down into its simpler fractions, a sum or difference of fractions, then it is integrable. How do you deal with a case like that? In previous videos, I dealt with some cases where we can write our fraction in the form a over x plus 2, for example, plus b over x minus 3, where the denominator has got such factors. Check my previous videos, you will find such kind of support. But what do we do when the denominator has got a repeated factor? What you do is you let this be equal to a over x minus 1. Please note that I have taken a linear factor out of this quadratic factor, just x minus 1. Then plus b over the whole factor x minus 1 squared. So in this case, you take a linear factor out of this, that is, you ignore the exponent, you have that denominator there. Then plus b over the whole factor. This is how you approach it, where a factor is repeated in the denominator. Now we proceed in the same manner in which I did the previous videos. In this case, I'm going to have x plus 1 over x minus 1 squared is equal to, let's express the right-hand side as a single denominator. So my LCD for that will be x minus 1 squared. Why this? This can divide there, and this can also divide there. So this is my LCD. Then I do the process of division. X minus 1 goes into x minus 1 squared, x minus 1 times. In other words, there are two x minus 1s that are multiplied together here. So if I divide this into the whole thing, one of them will go to leave me with x plus 1, by which I then multiply a. So a multiplies what I get there. So once again, x minus 1 goes into x minus 1 squared, x minus 1, sorry, this one is a negative, x minus 1 times. Then plus b multiplied by what? Now this quadratic factor into that quadratic factor, we are dividing a factor into itself, by the way. So that is 1. Okay. So I end up with x plus 1 over x minus 1 squared is equal to a open x minus 1 plus b over x minus 1 squared. Note that the fraction on the left is equal to the fraction on the right. And the denominator of the fraction on the left is equal to the denominator of the fraction on the right. That justifies the equality between the numerator on the left to the numerator on the right. So I am justified to say x plus 1 is equal to a x minus 1 plus b. Right. Then next, I take an x value, if x is equal to 1, for instance. Why x is equal to 1? X is equal to 1 will eliminate this part. If I put x is equal to 1 in brackets, 1 minus 1 is 0, 0 times a will be, sorry, if x is equal to 1, then here, let's start from here. 1 plus 1, I get 2 on the left is equal to, if I put x equal to 1, 1 minus 1 is 0, times a is 0, plus b is just b. So I've already found the value of b to be equal to 1, to be equal to 2. Okay, next, I find that there is no other factor on the right that will make either a or b disappear or vanish. So in that case, I'm going to pick another value of x, a convenient one, like 0, for instance, small enough to manage. So I'm going to take x equal to 0. If that is the case, the left-hand side will be 0 plus 1, which is 1, is equal to, if I put x equal to 0 here, that will be 0 minus 1, which is negative 1, times a is negative a, plus b. Then I utilize the value of b that I got earlier on, which is 2. I replace it here. Then I'm going to have 1 is equal to negative a plus 2. Taking negative a to the left, I have a equal to 2 minus 1, which is equal to 1. Therefore, the value of a is equal to 1. So a is 1, b is 2. What it then means is I can now come here and replace a with 1 and b with 2. By so doing, you will have split your composite fraction into 2 partial fractions, and that is how you deal with expressions that have got a denominator that has a repeated factor. Thank you very much.